All right, welcome everyone. Today we're going to be covering some simple yet powerful Flutter widgets for building responsive apps, that is, apps that adapt to the size and shape of a user's device. We're also going to be talking about some new APIs that help you interact with folding phones, and we'll also be talking about how your app can adapt to different types of inputs, such as mouse and keyboard. We'll top it all off with some quick rules to assist you on your journey to building an amazing adaptive Flutter app. My name is Tyler Holland, and I work on YouTube Create.
And I'm Reid Baker from the Flutter team. Thank y'all. Combined, we've got 12 years of experience in Flutter. As you may know, Flutter enables you to build on multiple platforms with one code base. Today, we're going to highlight how you can take an app built for a phone and make it beautiful on a wide range of devices, including foldables and tablets. Flutter already has some great existing resources, so we'll cover some of those and call out the notes and places you can follow up after while we're talking. To start us off, let's imagine you have a pretty simple phone app. It has a vertical scrolling list view with a large amount of items. We'll be using this demo app throughout the presentation as an example. This app looks great on this emulated device, but devices with cutouts and notches are pretty common. When we run this app on those latest devices, the app content gets blocked by the cutouts at the top of the screen. So how do we fix that? SafeArea. If you don't know about SafeArea, no worries. If you do and think it's simple, then get excited to dig deep about how Flutter makes SafeArea simple and easy to use. So SafeArea insets its child widgets to avoid intrusions like notches, camera cutouts, operating system UI like the status bar on Android or rounded corners of the display. If you don't want that behavior for all four sides, you can override it, but this is the constructor. It allows you to control it there. So how is SafeArea doing all of this? Let's look under the hood. This is a kind of a simplified version of SafeArea's build method. It's a pretty small widget. So how is it able to accomplish so much? The key is this MediaQuery.padding of. MediaQuery is a really powerful tool. It gives you lots of information, including the app's current window size, exposes accessibility settings like high contrast mode, text scaling, and if you're using an accessibility service like TalkBack or VoiceOver. Plus, it contains features of your device's display, like hinges or folds. We'll be referring to MediaQuery often and exploring more of its abilities. SafeArea uses some of this data to figure out how to inset its child widget. Specifically, it uses this padding property. And that padding property is the amount that's covered up by cutouts, notches, corners that I described earlier. So if MediaQuery's padding is really doing that hard work of identification, why not use it directly? Because SafeArea does one clever thing that makes it beneficial to use over raw MediaQuery data. It modifies its child's MediaQuery so that it appears as if the padding doesn't exist. What this means in practice is you can nest safe areas, and only the topmost one will apply padding when needed to avoid notches, like in the system UI. It may not seem like a big deal, but in practice, it's nice to know it's usually safe to use SafeArea. As your app grows and you move widgets around or you refactor code, you don't have to worry about having to understand exactly the intricacies of the widget tree. SafeArea will do the right thing on your behalf. Whereas if you used MediaQuery.padding directly, you would run into stacked padding. Jumping from the code example I showed earlier, a good place to start if this is a new concept or if you haven't heard of this widget before is in the body of your scaffold widget. I'll note you don't have to put it this high in the tree. It just needs to wrap whatever content you want to protect from those insets, but it's a really good place to start. For example, if you want your app to stretch underneath the cutouts, you can move SafeArea to wrap whatever content makes sense and let your app take up the full screen. This is what the app bar widget does by default, which is why we recommend wrapping the body and not the entire scaffold. So fantastic. Our app looks much better on modern phones. It won't be cut off. It scales well to future devices, including ones that haven't been shipped yet. So let's see what it looks like on a Pixel tablet. Oh no, that doesn't look great. The Android large screen app quality guidelines say we shouldn't have text and boxes take up the full screen width. So how do we do this in an adaptive way? I'll hand it over to Tyler.
Cool. Thanks, Reid. So Luckily, we have a couple of options. We can use the GridView widget to transform our existing list view into more reasonably sized items, or we can use the max width property on a container to not make the list go edge to edge. So let's start off with GridView. The GridView widget is very similar to list view, but instead of only showing a list of widgets arranged linearly, it can arrange the widgets in a two-dimensional array. GridView also has constructors that are similar to list views, which makes porting it easy. ListView's default constructor maps to gridview.extent, and listview.builder maps to gridview.builder. GridView has some additional constructors too for more custom layouts. If you're interested in finding out more, please check out the GridView page on api.flutter.dev. So for our example app, we're using a listview.builder, so we'll use gridview.builder. If your app has a large number of items, it's recommended to use the .builder function to only build the item widgets that are actually visible. So let's replace listview with gridview in our code. So most of the parameters are the same between the two widgets, so it's a straightforward swap. However, we do need to figure out what to set for this grid delegate parameter. Thankfully, there are some powerful grid delegates that are pre-made that we can use. Namely, here we go, sliver grid delegate with fixed cross-axis count and sliver grid delegate with max cross-axis extent. So they're both a mouthful, but all you need to know is that one ends with cross-axis count, which lets you assign a specific number of columns to your grid, and the max cross-axis extent lets you define a max item width, which is the cross-axis in our case. So it's tempting to use that grid delegate that lets us set the column count directly and then check if the device is a tablet and then hard code the value to something like 6 if it is. But we don't want to do that. We want to build an adaptive app that works on all sorts of devices, not just whatever our definition for a tablet device type is. So let's take a step back and think about why we would want to increase or decrease the number of columns in our grid. It's really the size of the window that we're currently rendered in, not the size of the physical device. This is a critical distinction because many Android and iOS devices support some sort of multi-window mode now, which will cause your app to be rendered in a space smaller than what the physical size of the display is. Web and desktop apps can also be resized in all sorts of ways too, and Flutter runs there. So this is why it's critical that MediaQuery contains the app window size rather than the physical device size. So instead of setting a hard-coded number of columns, let's have Flutter handle the adaptive part for us with the sliver grid delegate with max cross-axis extent. So we just need to figure out what we want the maximum width of our items to be. This can be a hard-coded number, and we're going to go with 250 for our app. What you choose for your maximum width will depend on the layout of your items and what you think looks best. So with those changes, here's what the app looks like now. It's still a bit crowded on the very large display of a Pixel tablet, though. Let's bring in a max width constraint to help with that. So all we need to do is wrap our grid view in a constrained box and give it a box constraints with the maximum width set. You can also use a container instead of a constrained box if you want some other functionality like setting background color, as they both do the same thing under the hood. For our maximum width, Material 3 recommends a value of 840 for the expanded screen size. So we're going to go with that. You can find out more about Material's layout guidance at m3.material.io. Now this looks much better. Notice how, because of how we set up our grid view, the number of columns automatically adapts to the new width of the grid. That's adaptive UI in action. So to wrap up what we learned in this section, grid view and constrained boxes max width can do a lot of the heavy lifting for making your app scale appropriately for larger screen sizes, while still maintaining the existing look and feel for smaller devices, like phones. Speaking of smaller devices, Reid's going to walk us through foldables.
Thank you, Tyler. So Android and Flutter both say in their design guidance not to lock screen orientation. And if you attended the talk on Android's adaptive guidance earlier today, they reiterated this a couple of times in their talk. But we see that developers in the wild sometimes do. So here's some typical app code that might lock your screen orientation if one side is less than 600 logical pixels. Inside of your app scaffold, you would call this handle size change method, and you'd pass in MediaQuery.sizeOf. looks reasonable, right? Like there's not like an obvious bug that's showing up here. At least this code remembered that you should add portrait up and portrait down, not just portrait, because that way your phone isn't locked in exactly one orientation. But let's see what this very common code does on a Pixel Fold. Oh, that doesn't look right. This folded display is okay when we're in this portrait folded mode, but when we unfold, let's break down what's happening there. So that we're using MediaQuery, like we discussed earlier, to figure out the window size of our app. When we restrict orientation, under the hood, set preferred orientations is causing Android to use portrait compatibility mode. That portrait compatibility mode puts you in this letterbox state. Unfortunately, once you are in this state, MediaQuery will never get a size that's bigger. Android's trying to help because we told it we only wanted to support portrait orientations, but because we limited that orientation, we made our own lives harder. Of course, you can avoid all of this by keeping all orientations supported. But if you're already restricting orientations, let me give you another way to avoid this without a lot of code. This is one of the few situations where you need the physical display dimensions and not the window dimensions. So in Flutter 3.13, which is 2 releases back, there's a new display API that allows you to get the physical screen dimensions. This object contains size, pixel ratio, refresh rate, and a couple of other interesting parameters. So here's some example code for how to get the display object. One key thing here is that you're finding the display of the view you care about. This is a forward-looking API that will hopefully handle the ongoing multi-display and multi-view work that Flutter's been working on for a number of years. Using that API, we modify, this is the exact same code as before. The difference is we have a display, and we're going to calculate the small size in logical pixels, and that will help us avoid that letterboxing issue. Now our app looks like we expect. If you're like me and working code is much more helpful than slides on a screen or a recording of a talk, the Wondrous app written by our friends at GSkinner is an example of a beautiful adaptive open source Flutter app that does this correctly. So you can check that code out on GitHub. But adaptive design is more than making widgets respond to space. We also need to be able to change what widgets are used. Tyler, can you walk us through how to do that?
Sure thing, Reid. All right, so some common use cases for dynamic widgets include dialogues, navigation UI, and building custom layouts. Let me show you the building blocks for making these while showing lots of code and doing it in a way that maintains readability. So to start off with, how do we even figure out what our app's window size is while in a widgets build method? We have 2 main options, MediaQuery, like we've covered before, and Layout Builder. So let's start with MediaQuery. MediaQuery contains a lot of data, but for this example, we're only interested in size property, which gives us the size of the app window in logical pixels, also known as density-independent pixels. That's the measurement for pixels that works best for us, as a logical pixel is roughly the same visual size across devices. So how do we get access to this size property? Through MediaQuery.sizeOf context. Using this method causes the given build context to rebuild anytime the size property changes. It's pretty neat. Our examples will demonstrate how this rebuilding works, as it's a bit indirect. Those of you familiar with Flutter may have used MediaQuery.of context before. So why are we using SizeOf instead? Well, as we alluded to earlier, MediaQuery contains a lot of data, and the .of method has that same rebuilding functionality on the build context that SizeOf does. If we use of instead, our widgets would rebuild when any of the MediaQuery properties change, which would result in a lot of unnecessary rebuilds. Thankfully, MediaQuery has specialized functions for each of the individual properties, so we can use SizeOf to only rebuild when specifically the size property changes. Moving on to Layout Builder, it helps us accomplish a similar goal as MediaQuery's SizeOf, but with some important distinctions. Rather than always giving us the size of the app's window, Layout Builder gives us the layout constraints from the parent widget. This means that we'll get sizing information based on the specific spot in the widget tree that you add the Layout Builder to. Additionally, Layout Builder gives you a box constraints instead of a size, so you're given a valid width and height range, the minimum and maximum, for your content, rather than just a fixed size. This can be useful for some more custom widgets, but for our purposes today, we're just going to be using the maximum values. So now that we have the tools for figuring out the size of our rendering area, let's jump into those examples. First off, dialogues. So for this example, let's imagine you have some sort of content that you want to show as a full screen experience on smaller devices and as a modal on larger screens. Flutter has a dialog class with two helpful constructors. One default one that will create a modal dialog, and another called dialog.fullscreen that will take up the entire screen. But how do we use two completely different constructors? We don't want to have to duplicate all of our code for our UI inside the dialog. So let's take a look at the constructors and see if there's any way we can share some code. They look pretty different, but they each share a child parameter. Since Flutter is built for widget composition, we can actually reuse nearly all of our dialog code. So for this example, we'll turn our image detail view into a dialog that's full screen on smaller devices and a floating window on larger ones. Let's dive in. To get it ready for reuse, we'll pull it out into its own stateless widget with the const constructor. The const constructor is ideal for performance since it lets Flutter know it doesn't need to reconstruct this widget instance during rebuilds. It's not required if you have a different use case here, but it's definitely preferred. So now that we've isolated our content widget, we can figure out how to switch between the two different dialog constructors. So we need to decide if we're going to use MediaQuery or Layout Builder here. We'd like the dialog to be full screen when our app window is small, regardless of where the button to launch the dialog is. Therefore, it makes sense to use MediaQuery's size of, so we can base the conditional on the app window itself. So with that figured out, let's implement it. In order to show the dialog, we'll call the showDialog function. This will live in our GridView image items onPressed. So this requires a build context and a widget builder, so let's add those. So now we need to fill the builder code to return a widget. We already know what our content looks like, at least, so let's create an easy reference to that to help with readability. It's time to make the decision on when exactly we want to show a full screen dialog versus non-full screen. The material guidelines suggest 600 logical pixels as a breakpoint between the extra small and small window sizes, so let's try that. We're using MediaQuery's size of function here to get we went over earlier to get the size of the app window. So now we just need the conditional to switch between the two dialog constructors based on our show full screen dialog variable. We're constraining the size of our non-full screen dialog as well, using the constrained box we learned about earlier. So that should be it. Let's see how it looks. Awesome. The dialog now becomes full screen when we hit that 600 width breakpoint. And this is happening because the build context we gave to MediaQuery's size of is rebuilt whenever the app window size changes, causing a reevaluation of our conditional statement. If you ran this code in a browser, you could resize the window and see the dialog go from full screen to windowed as the width changes, even while the dialog is open. That seemed like a pretty good methodology for switching between widgets based on app window size. Let's break down the steps we took and see if we can apply them to our next examples. So first, we abstracted. We analyzed the constructors for the widgets we wanted to use and abstracted out what we could share, like our dialog content widget. Next, we figured out the method of measurement. We determined if we should use MediaQuery's size of or layout builder, depending on if we want the size of the whole app window or if we want more local sizing. Last, we added branching logic. We used material design layout guidelines to determine when we should switch between the widgets. And I think that was it. So with those steps figured out, let's apply them to the next example, navigation UI. So let's follow that abstract measure branch methodology we created and see how it goes. In this example, we want to switch between a navigation bar when the app is small and a navigation rail when the app is big. What can we abstract and share between these two widgets? So we know we want a shared list of destinations to navigate to. Let's create a destination class to hold this info and define a destination as having a label and an icon. Now to create the navigation bar and navigation rail. Since each of these widgets have a large number of constructor parameters unique to each, I'm going to define each of them in their own stateless widgets to keep the code clean. Now to add in the shared data. We'll create its list of destinations programmatically with the destinations class we created earlier, set the selected index, and add a callback for when a destination is selected. That's a good amount of abstraction, so let's move on to the next step. Measure. Should we choose MediaQuery's size of or layout builder here? Well, we want the navigation to change based on the size of the whole app window, so we'll use MediaQuery's sizeof here. So let's implement it. Here we have our top-level scaffold widget, which will contain our bottom nav bar and side nav rail. Let's add in our MediaQuery sizeof call. But wait, when should this use side nav rail variable be true? Sounds like it's time for step 3, branching. The material guidelines, again, suggest that using a bottom nav bar for windows less than 600 logical pixels wide and a nav rail for those 600 or greater. It sounds like a good place to start. So let's add that number to our use side nav rail variable and move on to add the branching logic that we will use in our 2 widgets created earlier. Adding branching into the scaffold is a bit trickier than just a conditional because of how much the scaffold can do. To support the bottom nav bar, we'll use a ternary operator in the scaffold's bottom navigation bar param, and this will add the bottom nav bar if we aren't using a side nav rail, or set the bottom nav to null if we are using a side nav rail. Navigation rail is a little bit different because it actually lives in the body content of the scaffold. We'll wrap our existing content in a row and wrap that with an expanded so it takes up all the available space. We'll then conditionally add in the side nav rail based on our variable. And now we have a navigation solution that adapts to our app's window size. We left out a lot of details in that example, but there's a great code lab called Building an Animated Responsive App Layout with Material 3 if you want a more in-depth and step-by-step guide to building an adaptive nav rail and bottom nav combo. It even shows you how to animate between the two. For our last example, let's build a custom layout for our image details view. We'll put our caption, description, and tags below the image if our container is not very wide, and to the right side of the image if it is wide enough. So following that process again, let's extract the shared widgets to allow for reuse. In this case, it's the image, caption, description text, and tags widgets. Next, should we use MediaQuery or Layout Builder? For this content widget, we want the sizing to be based on whatever space is given to specifically our widget, not the app window in general. So in this case, we'll use Layout Builder. Now to figure out when we want to switch between the layouts. First, let's do a rough sketch of the layouts and see what makes sense after that. We want the wider layout to look like the layout on the left, and with the image on the left and the text to the right. For our less wide layout, we want to look like the layout on the right, with the image and texts all stacked on top of each other. It seems like a simple solution here would be to use the wide layout when our given space is wider than it is tall, and to use the tall layout in the opposite case. So let's see what that looks like in code. First, we'll create our branching logic. Layout Builder's constraints parameter has the data we're looking for, the max height and the max width our widget is allowed to take up. Let's add an is more tall than wide variable to store the answer to that question. Next, we'll branch on that value. And then add in our layouts. Now our details screen has a nice responsive layout, and since we use Layout Builder, we know we can take this widget and put it anywhere in our app and size it however we want, and it will still look great. So let's review those steps for using a different widget based on app window size. First, abstract. Look at the constructors for the widgets, abstract out what you want to share, like destinations in our nav example, or content widgets for dialogues. Second, measure. Determine if you should use MediaQuery's sizeof or Layout Builder. Use MediaQuery to get the size of the whole app window, or Layout Builder for more local sizing. Last, branch. Add the logic for when you want to switch between the widgets using logical pixels. You can refer to the material design layout guidelines for measurements. And that's it. So with those steps, you'll be able to use different widgets at different size breakpoints in your adaptive app. I'll pass it back over to Reid to talk about another important adaptive concept, inputs.
Chances are, if you built an app for a phone, you were primarily thinking about touch input as your only input mechanism. Adding tablet support includes expanding input controls. So in the tier 3, which is the lowest level of Android's large format device support, it includes that you need to support mouse and stylus input as one of your required input modes. Sorry. I wanted to go back. Okay. Sorry, it includes mouse and stylus input mode. So what's really cool is that Flutter, because you're one shared code base, if you use mouse support if you build mouse support for Android tablets and you decide to ship on Flutter desktop or the web, that code transfers over. The same is true. If you're already shipping a Flutter web app, odds are your Android app already has mouse and keyboard support built in. And as a developer, it's a cool note. You can use one to help validate the other. So it can be really easy to be like on your desktop and iterate really quickly. This is one of the cool perks of Flutter. So I'll start with the good news. If you're using Material App Theme and its buttons and selectors, then you already have support out of the box for various additional input states, and they work for you for free. But what if you have a more custom widget? Let me show you how to add interactivity for hover and D-pad selection. So here we have this grid of images from our demo app. The existing code, I'm showing you this to show you it's not very complicated. It's a container with some formatting and an image. Here's the kind of an abbreviated version of the GridView code for readability. What this code doesn't do is handle D-pad or mouse hover states. So before we get to what widgets you need to trigger a UI change, let's add this Boolean I'm going to call focused and a setter which we'll use to trigger the UI for a change. So this is a little method we're adding. If the image is focused, we're going to give the corners a little bit of a radius. And that's all. Like this is as simple as it takes. So when I was first figuring out how to implement the custom selection and hover states, I found the focus and focus scope widgets, which if you search, this is kind of what comes up inside of Google. They ended up not being the best widget for me. They're super powerful, but it wasn't what I wanted. Instead, I found this class, this widget called Focusable Action Detector. It's frequently used in the material library, and it combines the functions of actions, shortcuts, mouse region, focus, and it gives you things like key bindings and callbacks for handling those many state changes. It really bundles it all up and makes your code much easier to handle. So we're going to add a focusable action detector in this code. For simplicity, I'm going to use that setFocus method for both hover and highlight state. So if it's highlighted, call setFocused. On hover highlight, we're also going to set focused. You can have those be different if you want. So here is a little video of the corner radiuses kind of navigating around. That's okay, but this is a talk about making your app beautiful. Let's make this a little bit more obvious. So we're going to add some transparency so it's easier to see what's selected. And let's animate those transitions because that's really too abrupt. So our container becomes an animated container, pretty simple. And we wrap the whole thing in an opacity widget and set the opacity if focused is true. So here is a little video of that happening. As you can tell, it's much prettier. You can tell what's selected and the corners animate in and out. Oh, sorry. So for our final topic, Tyler, what are some best practices you can share?
Yeah, thanks, Reid. So, through my own experience and with talking with my coworkers, a few topics came up that are more mechanical or less mechanical and more philosophical. First off, as mentioned earlier, don't lock the orientation of your app. An adaptive app should look good on windows of all different sizes and shapes. So, while locking an app to portrait mode can help narrow the scope of a minimum viable product, it can increase the effort required to make your app adaptive in the future. For example, the assumption that phones will only render your app in a full screen portrait mode is far from a guarantee. Multi-window app support is becoming common, and foldables have many use cases that work best with multiple apps running side by side. If you absolutely need to lock your app to portrait mode, remember to use that new display API covered earlier in the talk, instead of something like MediaQuery, which you might have used before. We've included a link to the blog post detailing the change as well in the show notes. Secondly, while building your app, try to break down large, complex widgets into simpler, smaller ones. As demonstrated in our navigation rail, dialog, and custom layout examples earlier, refactoring your widgets can reduce a lot of the complexity that comes with adopting an adaptive UI by sharing core pieces of code. There are other benefits as well. On the performance side, having lots of small const widgets can help improve rebuild times over having large, complex widgets. Flutter is able to reuse const widget instances, while a larger complicated widget will have to be set up every time there's a rebuild. From a code health perspective, organizing your UI into smaller bite-sized pieces helps keep the complexity of each widget down. Less complex widgets are more readable, easier to refactor, and less likely to have surprising behavior. There aren't any specific guidelines on what makes a complex widget, but what we like to do is document the behavior of a widget in a Dart doc and judge the complexity of that based on the documentation. So, is it just a few sentences and relatively quick to understand? It's probably a good size as is. Do I need to write a small story to cover all of the different behaviors a widget can exhibit? It's probably too big, and we should try to break it down a little bit more. Next, avoid writing code that checks for if the device you're running on is a phone or a tablet or any other specific type of device to make layout decisions. What space your app is actually given to render isn't always tied to the full screen size of the device. Flutter can run on many different platforms, and your app may be running in a resizable window on Chrome OS, side by side with another app on a tablet, in a multi-window mode, or even in picture-on-picture on phones. Therefore, device type and app window size aren't really strongly connected. Instead, use MediaQuery to get the size of that window your app is currently running in. We had some examples of that earlier in the talk with navigation UI and dialogues. This isn't just helpful for UI code either. Check out last year's talk, Flutter Lessons for Federated Plugin Development, to find out how abstracting out device capabilities can help your business logic code as well. Finally, avoid using MediaQuery's orientation field or orientation builder to switch between different app layouts. This is similar to the guidance of not checking device types to determine screen size. The device's orientation also doesn't necessarily inform you of how much space your app window has. Instead, use MediaQuery's size of or layout builder, and use adaptive breakpoints like the ones the Material website recommends. Breaking your UI into compact, medium, and expanded layouts is a good place to start. The compact layout can be used when your app window is less than 600 logical pixels wide, medium's between 600 and 840, and expanded is used for everything 840 and above. Again, those are just good places to start and not mandatory. You can use whatever breakpoints and groupings make sense for your app. Maybe you're building some sort of gaming app that wants to run on TVs. It would make sense to add some sort of lean back breakpoint that kicks in at 1280 logical pixels of width for 720p displays, or some combination of app window size and pixel ratio, which is also available through MediaQuery's device pixel ratio of. So with these best practices, hopefully your journey to making an adaptive Flutter app will be as smooth as possible. If you'd like to learn more Flutter tips and best practices, check out the Flutter channel on YouTube, or the new documentation on flutter.dev/adaptive for further guidance. We just did a really big redesign of these docs with the latest best practices and code samples, so definitely check it out.
So if you've been asleep, it's the very end of the day. Let's recap what we've covered. We discovered how to keep our UI safe from screen cutouts using the SafeArea widget. We adapted our portrait-locked phone UI to something that looks great on larger screens with GridView and constrained box. We learned a new display API that helps our apps work better with foldable devices. We worked through examples of how to change our app layout based on window size using MediaQuery and Layout Builder. We added support for different input methods and input modalities to share code across devices and learned a simple method for selection animation. And finally, we finished everything else off with some quick tips and best practices.
So thank you everyone for joining our talk.